need to type the location, the address. For example, I'll type the city and see whether my city can be detected or not. I'm typing Ponton. Let's see whether Ponton is getting detected. Yes. Ponton is this location, and you can, by default, you can select the NRER International, and then the database of the, normally for solar simulation, we need the solar radiation. So for that, there is a TMY2, TM3 files. These are all solar radiation data files, which are either available through the satellite data or through the actual weather monitoring facilities. So basically, we depend on satellite data or the actual data of the weather station. So in this case, by default, it is showing the Kuala Lumpur location. So it is, which is 132 mile away from this location. So it is taking the weather data of KL to do the simulation of the this quantum location. It's still reasonably acceptable because of similar weather condition, but however, if it is different kind of weather and climate, I think this may not be reasonable. But it's always good to have a exact climate data of this location. So for this simulation, the system is taking the Kuala Lumpur database for this purpose of simulation. Okay. Then I go to the next step where I will provide the system information. So here I have the options of doing the simulation by knowing the capacity. First, as in previous class, I have given an idea about how to do the capacity sizing of the solar system according to your energy load, according to the load requirement of the building. So if you know the load, the total load of the building, accordingly you can fix the capacity. So let's say I fix a capacity of 5 kilowatt. Okay, for my house I need a 5 kilowatt system, and then I can choose a type of module, whether I go for a standard module or a premium module or thin film module. So we have three options. So you can.
What are the differences, standard, premium?
Yes.
Oh. The difference of standard and premium.
Yes.
Difference of standard and premium, sir.
Okay. I'll explain to you. So now you're able to see this. You're able to see the screen?
Yes.
Okay. So if you can see this one, they given the standard as crystalline silicon with the efficiency of 15%, and for the premium one, they are taking 19% efficiency with anti-reflective coating. So the main difference with the efficiency of the system. Okay, the thin film has got 10% efficiency. So we choose either of this. So for the time being, I'm choosing a premium one with a higher efficiency. Then we can choose the type of system, whether it is a fixed system or if it is a roof mounted system, or is it single axis system, or is it 2-axis system, or 1-axis backtracking. So we have so many options. If it is a building one, normally it is called roof mounted. If it is land-based system, we call as open track. So if you want to know the description about all the systems, you can find it here. What is the fixed and tracking systems? You will get the detail here. So 1-axis PV tracking, this is a fixed tilt. This is 1-axis tracking where you can track according to the only one angle, but here 2-axis, you can actually both the axis you can do, X and Y axis, you can do the tracking. So basically you can orient both latitude and longitude wise, you can do it. So this is the advantage of 2-axis tracking. Normally, if it is a land-based system, I keep open, but let's say I plan for a 5 megawatt for a rooftop system. So I take it as fixed roof. Then the system losses, this also by default it is giving, but you can actually change this value according to the location. Some location may have less losses, some location may have more losses. This one depends on the site only. Sometimes higher temperature will lead to more temperature loss. Suppose if there is more dust and other area, this value also increases. So this one totally depending on the location. So you can find different values of it. The system losses, you can see soiling, shading, snow, mismatch, wiring, light induced degradation, availability, nameplate rating. So all this thing put together, roughly 14% should be reduced actually. But you can also increase it in case if it is old panel, or if it is a snowfall region, you should increase this value. And if high temperature, then we need to increase this light induced degradation. Likewise, there are some factors which we may increase slightly depending on the location. For example, soiling, if there are more dust and other things, we increase this. If you have tall buildings and tall objects, then we need to increase this value. So this can go up to some value, but default value we are taking as 14%. So I am taking as, let's say, 15%. Then tilt angle, we need to fix it. This depends on the location again. We need to do the simulation and then only we know the tilt angle. So the tilt angle should be optimized according to the location. So for the time being, let me take it as 10 degree. Azimuth is always 180 degree for the northern hemisphere, and it is 0 degree for the southern hemisphere. And you can know the difference. So azimuth angle is north facing, south facing is 180 degree. If it is north facing, 0 degree. Normally in our case, we always face south. So south facing means 180 degrees azimuth angle. And then the other parameters, or if you want to do the cost calculation, you can actually put the tariff. Suppose you have a grid connected system and then you want to sell the power, it's a residential system, and then the tariff, you can actually put the tariff. So what is the tariff for 1 unit? Roughly how much is the electricity cost here for 1 unit?
Need to check the bill, sir.
How many cents? 20 cents? 30 cents?
Not sure, sir.
I am putting 20 cents, okay? 20 cents per unit. Then you can run the simulation. So on an average, you can download these results. So here you will get the results in a PDF file, which will cover the solar radiation first. How much is the solar radiation available on the given location? On an average, we have 4.25 kilowatt hour per meter square per day. Monthly one, you can see 4.39, 4.5. This is one which we actually try to find out this value, because using through Google also we can do that. I shared one video how to find this value for any location. The same way, the software is able to do this, and it is taking the annual average value of 4.25, and the amount of energy which we can generate month-wise from January until December, it's already given. So normally it is good to express the energy in terms of annual output, annual energy output. So we have the annual energy output as 5,884 kilowatt hour per year. And every month, if you can save this energy, if you use this energy, and this energy you are basically saving, right? You are not paying for it. So how much monthly you can save? You can save 103 ringgit. Here for February, you can say 96 ringgit. And for March, you can save 108. This value will increase if the energy is more. For example, during the month of March, we generate more energy. Therefore, the amount of savings, the money savings is very high during the month of March. Whereas the savings are very less during the other month, because correspondingly the solar radiation is less. Solar radiation is less, the annual energy output is also less. So I did a simulation to find the the energy output of the system at an angle of 20 degree, right? The tilt angle I kept 20 degree, and I kept the fixed system. So for the 20 degree, I got 5884. So let me change this and see what other results I get. So this is the summary of it. You will find the content. The weather data is taken from KL. Latitude, longitude is this. We have taken a residential building. We have chosen a 5 kilowatt system, a premium module, and array type is fixed roof mounted type. The tilt angle is 10 degree. Azimuth angle is 180 degree. System losses is 15 degree. Inverter efficiency is 96%. And DC to AC cable size is 1.2. So the average retail price we assumed as 20 cents per unit. And the capacity factor, what we get is 13.4%. This is the result. This is the capacity factor result. And the energy result is this. Energy result is this. So basically we get two answers. Performance is based on the energy generation, the annual energy generation. The other one will be your capacity factor. So these two are the performance metrics for this one. You can also do here monthly or hourly, like that. You can download the results. You want to do the hourly calculation also, you can download in an Excel sheet. So this is done for an angle of 10 degree. Let me try to increase and see what happens. The tilt angle, because we don't know the optimum one. So I try to increase the tilt angle. I keep it 20 degree now. So previously for 10 degree, I get 5884. Now, how much I am getting? 5884. Now it has reduced to 5735. So 20 degree is getting less output. So, okay, let me try for 15. Let me try for 15 degree. 15 degree I get 5823. So I get 5823, which is also less than 5884. 5884 is 10 degree one. Let me do for 12 degree. 12 degree tilt angle. 12 degree tilt angle 5862, still lesser than 5884. So let's I do for 11 degree. 11 degrees 5874, which is less than the 5884, which was 10 degree. So 10 degree one is getting higher energy, 5884, but beyond 10 degree I cannot reduce also, because it will be perfect flat. So rainfall comes means it becomes stagnant. So it is not advisable to keep low tilt angle, though it may give higher output. See, it's giving higher output, but I cannot keep it 9 degree and all. So there should be some optimum value in which we need to fix. So normally we should fix at 10 degree or slightly higher is always good. So in that way we can find out what is the optimum tilt angle. And then you can perform the simulation. So this we can run the simulation for different conditions. One of you can run for standard module. The other one can run for premium module. One of you can run for thin film module, keeping this constant. Then you can run for fixed rack module. Then you can do it for one axis module. So likewise, we can do different combinations. And then we can also optimize the tilt angle of the system. So tilt angle, you can put trial and error. Initially, we start with a small tilt angle and keep on increasing the tilt angle and find which particular tilt angle give better results. So this exercise we can do by just varying the tilt angle. This we cannot vary because south facing 180 degree we need to keep. This one 5 kilowatt we fixed because we found the load. What is the load? According to the load we found 5 kilowatt. But again, this one depends on the how much load you are connecting. We need to do the calculation for the load and then fix the capacity. So normally for a rooftop system, 5 kilowatt is good enough for a normal household. But it again, you need to calculate it correctly if at all you want to do this one. Okay. This is a small exercise which I would like to demonstrate. In the same way, I will demonstrate the other one. Let me check whether it's working or not. I need to search PV GIS. PVGIS. So here you will find PV performance tool, TM by tool. There is typical meteorological year, that is meteorological data. Solar radiation data, you have monthly, daily, hourly. Then you have PV performance tool. So I choose the PV performance tool. Then basically we need to select the location. So we need to go to this location and then choose whichever location you want. Okay. So we choose the content one. This is the latitude, longitude. Okay. So here the simulation, what I'm going to do, I use here the type of module is crystalline module, CAS and CDTE. So let me choose a crystalline module. And I use a capacity of 5 kilowatt. System loss, like previous case, we take 15%. Then what type of mounting you want to have? Is it freestanding or building integrated? Okay, let's say I keep building integrated. Then you can keep the slope. What angle I'm going to keep? I'm going to keep it at 10 degree. Azimuth, what angle I should keep? 180 degree for south facing. And you want to include PV electricity price, you can actually do it. So let's say 20 cents is my electricity cost. Interest rate, let's say 3%. And then lifetime, let's say 25 years. And then I can quickly do a simulation here. Here I choose crystalline silicon, okay? System loss 15%, building integrated. If you want to optimize slope, you can choose this option. Optimize slope, optimize slope and azimuth both. So you can also, azimuth angle also you can, so I said exact south, but in some case slightly north-south, slightly northeast, southeast, like that, it can be altered also. So you can try doing optimizing the slope and azimuth angle. Then you can visualize the results. So if you see the results, you can see the monthly energy generation. Monthly energy generation 471, all these things. So you get the energy, and then the annual average. So you can see here the PV output. This is a PV output. Onto radiation. This is monthly radiation. Okay. You want to download this? You can download the PDF file. Okay. So this will give the fixed how much energy you are producing, what is the in-plane solar radiation, month-wise solar radiation. And in case you want to, the yearly PV production is 6406 we are getting. Previous case, we got 5884. In this case, optimizing the tilt angle and azimuth angle, this saying actually 1 degree is optimum is saying, and the azimuth is saying 29 degrees optimum. But practically speaking, 1 degree tilt angle is not at all good enough. Similarly, azimuth 29 degrees is not at all optimum. So what we can do is we will remove that option. We will not optimize it. We will not optimize anything. We just go for visualization. So now without optimization, we gave 10 degree and azimuth 180 degree. So our annual energy is how much now? 6332. 6332 is our annual energy. Solar radiation availability is 1778.24. So this is our key results. This one you can also vary. Crystalline silicon, you can play with this technology. You can try CAS, or you can try with CDTE. Like with a different module, you can get different results. So this is another tool. And you have the options to download the results in either in the PDF file or in the graphical plot. Okay, so for all these two softwares, you need to have this system capacity detail. You can also try tracking arrangement. You want single axis tracking, two axis tracking, you can do it. If you want to design an off-grid system, which is a battery operated system, we need to define the battery capacity, discharge, what is the energy consumption per day. You need to upload the consumption data, you can design the off-grid system. And solar radiation database, either you can take from the software or you can actually take it by the Google Earth. So it takes automatically the solar radiation data from satellite. Or in case you have the data, you can actually upload also. It depends on that. So this software can do both the grid connected system as well as off-grid system. Off-grid system is battery. Grid connected system is grid interactive without the battery. So this is the advantage of this software, which is PV GIS. This tool is basically given by European Commission, whereas this tool PV Watt is given by the NREL, US based one. So that is the only difference. This is US based and this one is based on European Commission. So both the tools are similar, more or less have the same feature, but slight difference you will find here with all this one. Okay, so maybe I will request you to do a quick simulation from your side, and I will ask one exercise maybe from each team member can demonstrate to me now. Okay, I'll stop this recording. Okay, thank you.